Negative feedback. Negative feedback is the process of returning a portion of the output signals to the input with a phase angle that opposes the input signal. So here is the negative feedback circuit. An OpAmp can be connected using negative feedback to stabilize the gain and increase frequency response. Non-inverting amplifier. A non-inverting amplifier is a configuration in which the signal is on the non-inverting input and a portion of the output is returned to the inverting input. Feedback force Vf to be equal to Vin, hence Vin is across Ri. With basic algebra, you can show that the closed-loop gain of the non-inverting amplifier is ACL non-invertings is equal to 1 plus Rf over Ri. Examples. Determine the gain of the non-inverting amplifier shown, given Rf is 82K, Ri equal to 33K. So as a solution, ACL non-inverting equal to 1 plus Rf over Ri. Therefore, ACL is equal to 1 plus 82 k ohms over 3.3 k ohms, and ACL is equal to 25.8. Inverting amplifier. An inverting amplifier is a configuration in which the non-inverting input is grounded and the signals is applied through a resistor to the inverting input. Feedback force the input to be nearly identical, hence the inverting input is very close to 0 volt. The closed-loop gain of the inverting amplifier is ACL's invertings equal to negative Rf over Ri. Okay, now determine the gain of the inverting amplifier shown, given Ri equal to 3.3K and Rf equal to 82K. So now we know the formula for ACL's invertings is equal to negative Rf over Ri. Therefore, ACL inverting is equal to negative 82K over 3.3K. And ACL inverting is equal to negative 24.8. The minus sign indicates inversions of the gain. Impedance, non-inverting amplifier, and I. Zin Ni equal to 1 plus A open loop B times Zin, generally assumed to be infinite. Z out non-inverting is equal to Z out over 1 plus AOLB, generally assumed to be 0. Inverting amplifier. Z in inverting equal to approximately equal to Ri. Z out inverting is equal to Z out over 1 plus AOLB, where B is the feedback attenuation, where B is equal to Ri over Ri plus Rf. In the previous slide, you learned about the principles, operation, and characteristics of the operational amplifier. Therefore, in this section, two fundamental important circuits are covered to give you a foundation in OpAmp circuit. Basic OpAmp operation circuit. Operational amplifiers are often used as comparator and summing amplifier. Comparator. A comparator is a specialized nonlinear OpAmp circuit that compare two input voltage and produce an output state that indicate which one is greater or less. Comparators are designed to be fast and frequently have other capability to optimize the comparison functions. In this application, ON often used in the open loop configurations. With one pin for input voltage and one pin for reference voltage. Comparator also used to determine when an input voltage is exceed a certain level. Zero-level detections. This figure shows a zero-level detector. In this situation, inverting input is grounded to produce a zero level. Input signal voltage Vin is applied to the non-inverting input. Because of high open loop voltage gain, a very small difference voltage between two inputs drive the amplifier into saturation, causing the output voltage to go to its limits. Figure B shows the result of the sinusoidal input voltage Vin applied to the non-inverting input of the zero-level detector. When sine wave is positive, the output is at the maximum positive level. When the sine wave cause 0, the amplifier is driven to its opposite state and the output goes to its maximum negative level. It can be used as a squaring circuit to produce a square wave from a sine wave. Non-zero-level detections. A zero-level detector from previous slide can be modified to detect positive and negative voltage by A. Connecting fixed reference voltage source such as battery to the inverting input as shown in figure A, or a more practical arrangement by using voltage divider reference as shown in figure B, and a slide show for figure C is the circuit use Zener diode to set the reference voltage. The basics operations of non-zero-level detection is shown in figure D. When V in is less than V reference, the output remains at the maximum negative level. When V in is approximately equals or greater than V reference, the output goes to its maximum positive voltage. The summing amplifier is an application of the inverting OpAmp configurations. There are 4 types of basic summing amplifier, which are summing amplifier with unity gain, summing amplifier with gain greater than unity, averaging amplifier, and scaling amplifier. This figure shows 2 input summing amplifier and 2 voltage V in, V out applied to the inputs and produce current I1 and I2. This forms the total current IT equal to I1 plus I2. Since V out is equal to negative I total times RF, the following step apply. V out is equal to negative I1 plus I2 times RF, where I1 is equal to V in 1 over R1 and I2 is equal to V in 2 over R2 times RF. If all 3 of the resistors are equal, R1 equal to R2 equal to RF equal to R, then V out is equal to negative V in 1 over R plus V in 2 over R times R. If we simplify the equation, we will get V out is equal to negative V in 1 plus V in 2. Therefore, a general expression is given in this equation for unity gain summing amplifier with an input where all resistors are equals. V out is equal to negative V in 1 plus V in 2 plus V in 3 plus V in N. Examples. Determine the output voltage in figure. Given V in 1 is equal to 3 volt, V in 2 equal to 1 volt, and V in 3 equal to 8 volt. All resistor is similar, which is 10K. Therefore, V out is equal to negative Vn1 plus Vn2 plus Vn3, and V out is equal to negative 12 volt. Summing amplifier with gain greater than unity. When RF is greater than R, which is input resistor, the amplifier has a gain of RF over R, where R is the value of each equal value input resistor. Therefore, for summing amplifier with gain greater than unity, the equation or formula for V out is equal to negative RF over R times V in 1 plus V in 2 plus V in 3 plus V in N for N input. Okay, now examples. Determine the output voltage for the summing amplifier in the figure. Given V in 1 is 0.2 volt, V in 2 is equal to 0.5 volt, and R1, R2, RF, R1 and R2 is equal to 1K, while RF is equal to 10K. Therefore, V out is equal to negative RF over R times V in 1 plus V in 2. Substitute all the value in the equation, so we will get V out is equal to negative 7 volt. Summing amplifier, averaging amplifier. An averaging amplifier is basically a summing amplifier with the gain set to RF over R is equal to 1 over N, where N is the number of inputs. The output is the negative average of the inputs. Show that the amplifier in the figure produces an output whose magnitude is the mathematical average of the input voltage. So the general formula is RF over R is equal to 1 over N, where N is the number of the inputs. So now we have 4 input, V in 1 1 volt, V in 2 2 volt, V in 3 3 volt, and V in 4 4 volt. The input resistor are equals, where R is equal to 100K. Therefore, the output voltage is V out equal to negative RF over R times sum of input voltage V in 1, V in 2, V in 3, and V in 4. So, V out is equal to negative 2.5 volt. Okay, now, summing amplifier scaling adder. A scaling adder has 2 or more input with each input having a different gain. The output represents the negative scale sum of the input. Therefore, the formula for V out is equal to negative RF R1 times V in 1 plus RF over R2 times V in 2 plus RF over R3 times V in 3 plus RF over Rn times V in n. Okay, examples. Now we are given a OpAmp circuit as shown in the figure. So every input voltage has different resistor value. We have 3 input, V in 1 3 ohms, V in 2 V in 1 3 volt, V in 2 2 volt, and V in 3 8 volts. Now for R1 the value is 47K, R2 is 100K, and R3 is 10K, while our reference RF is equal to 10K. So now, weight of input 1 RF over R1 is equal to 0.213. Weight of input 2 RF over R2 is equal to 0.100. Weight of input 3 RF over R3 is equal to 1. Therefore, the output voltage V out is equal to negative RF over R1 times V in 1 plus RF over R2 times V in 2 plus RF over R3 times V in 3. Therefore, V out is equal to negative 8.84 volt. Okay guys, I think that's all for chapter 4, operational amplifier. So after this, we will discuss a few examples and tutorial 2. Okay guys, thank you.